Since I was in medical school, it has long been of concern that there could be a highly transmissible, highly lethal respiratory virus that could spread throughout the world very quickly.
WHO described it and they said it's going to jump from animals into humans. It'll cause a global pandemic. There'll be massive economic disruption.
Some people have called it disease X.
In just over 3 weeks,
has now
there have been
become
1,000
the
deaths.
epicenter of the pandemic.
Filmed as the pandemic unfolds.
Can you hear me?
Yes, I do. Is that better?
This is the story of how scientists and doctors are battling the deadly new virus.
Brian, how's that?
Perfect.
It was like a horror story.
Revealing how the virus is ripping through America.
We think we have it very well under control.
You know, if we had had better testing, if we had been on top of it, maybe we'd have a very different 2020.
Why the search for a cure is so challenging.
Even if you stop the virus, the body's immune system has gone completely awry.
Inside the race to create a vaccine.
We need to move really quickly because pretty much everybody in the world is likely to be infected, and so we could potentially still see millions of deaths.
This is the story of the first critical months of a global pandemic. Scientists estimate that wild animals could be harboring more than 1 million undiscovered viruses. It takes just one jumping to humans to start a pandemic.
The first patient came into our hospital. This patient is the 53 years gentleman, and he came to the ER with the difficult breathing due to the severe and also intubated already. We don't know the etiology of this pneumonia.
China is slow to alert the world as cases of the mysterious disease keep coming. Doctors connect 27 infected people to a wet market where wild animals are slaughtered for food. Any one of them could have been carrying a single virus that mutated and jumped to a human.
Which is called animal pneumonia.
In Australia, virologist Eddie Holmes has spent years investigating how viruses emerge.
This report of these pneumonia cases in Wuhan, that was immediately very interesting to me. We've been doing for a number of years sampling animal populations around Wuhan. And I've been to this famous market that was been talked about quite a lot, so I got photographs of that market. So then I immediately contacted my colleagues in China to see whether I could help, because it was obviously, I think, a concern.
It's standard procedure to use genetic sequencing to try to identify emerging diseases. Scientists in China analyze a sample from a patient who worked at the wet market.
It was very clear they had a very, very high number of hits, matches to a coronavirus.
Some coronaviruses cause the common cold. But this new type is strikingly similar to a far more dangerous one, SARS.
SARS was the same family, it's in the coronaviruses.
In 2003, the SARS virus killed nearly 800 people, around 10% of those infected. Scientists believe it originated in bats. Could history be repeating itself?
Coronaviruses just are particularly adept at jumping species backwards. They're just very good at it. Bat viruses rarely jump directly to humans. It can happen. I suspect also there's another animal in there as well.
SARS spread to 26 countries. Scientists fear this new coronavirus might have similar deadly potential. Once analyzed, the genetic code should reveal crucial clues to where it comes from and how it might be stopped.
With a colleague in Edinburgh, we got the genome sequence, and I had it in my possession for, I think, like 52 minutes, just past midnight on the 11th of January. I released the sequence of the virus online so that the whole world could then take a look at it, because we had to get it out there.
With the outbreak growing in Wuhan, the release of the genetic code sparks an unprecedented scientific effort. Hundreds of researchers around the world join the race to develop a vaccine. Out in front, one of the world's top vaccinologists.
We were looking to see, was there confirmed human-to-human transmission, and there was. As soon as the sequence was released from China, we started working on the vaccine, and that has enabled us to get going fast.
Sarah's lab has a head start because they've already developed an experimental vaccine for another deadly coronavirus. Trials showed the MERS vaccine was safe for humans.
We were really just thinking about probably doing a first clinical trial and then stopping, because the expectation was that the outbreak would be contained in China, much as SARS was, but more quickly.
The SARS virus was deadly, but ultimately easy to control because it was transmitted by people with obvious symptoms. Isolating them contained the virus before it could spread.
We thought it may not go very far and we won't need the vaccine.
Sarah is not the only scientist yet to wake up to the scale of the threat posed by the new virus. One leading immunologist is in for a shock.
I go to lots of conferences. I'm always away, actually, to be honest. And I've realised much of the science doesn't happen in the scientific sessions. It happens in the bar or, over a cup of coffee. And that's when you really get ideas going.
At a routine conference, the talk in the bar is anything but.
The German collaborator of mine, he works with the guy who discovered SARS, right? And he says to me, this guy's worried. I said, what? He said, yeah, he's predicting 70% of the world will be infected. He said there'll be like a 10% mortality if it's like SARS. And all our jaws dropped. I said, what the hell is this? And I remember in the bar, right? And we all go quiet. And I said, Ike, say that again? He said, yeah, the world expert on SARS is saying this is going to be really serious. The fact that it was spreading faster worried these people.
In Wuhan, the virus is spreading rapidly. In Dr. Peng's hospital, one patient alone infects 10 healthcare workers and 4 other patients with coronavirus.
We didn't know how severe this virus spread. Generally, we found spread faster, especially in the hospital, and infected medical professionals as well as the patients.
It dawns on Dr. Peng this outbreak could be much worse than SARS.
Compared to SARS, this virus spread faster, spread frequently.
As Wuhan locks down, the most urgent question for scientists is, how does the virus spread so quickly? Just over 2 weeks after its emergence in China was first reported, the virus arrives on American shores. A 35-year-old man is on his way home to Washington State after visiting family in Wuhan. Complaining of a cough and a fever, he's quickly isolated by health officials, becoming America's first reported case of coronavirus. In the next 10 days, American cases rise to 6. President Trump offers reassurance.
We're working very strongly with China on the coronavirus. That's a new thing that a lot of people are talking about. Hopefully it won't be as bad as some people think it could be. We think we have it very well under control.
His optimism is misplaced. The virus is spreading with alarming speed. From Wuhan, across Asia, to Europe, and North America. On January 31st, President Trump bans travel from China.
The question of whether travel bans work is complicated. The China travel ban was only for people, foreign nationals, so people who are not citizens of the United States. So there are exceptions to them. I think it's probably fair to say that the one that the Trump administration did slow things down a little bit. A travel ban is not going to, as Trump put it, like shut it down.
Classic infection control relies on testing people to find out who has the virus and isolating them. But America has a problem. The country's top infectious disease agency, the CDC, insisted on developing its own test rather than use an existing one. As it is rolled out to state labs, it becomes clear the test is flawed, and it takes weeks to figure out a fix.
Testing in the United States was a complete debacle. And this was at a crucial time. We really needed good tests. Doctors were trying to figure out who to isolate in hospitals. You know, if we had had better testing, if we had been on top of it, we could have had those first outbreaks diagnosed, gotten under control, and maybe we'd have a very different 2020.
By early February, the virus appears to be unstoppable. And scientists are about to discover a big reason why.
Thousands of passengers are being holed up on a cruise ship in Japan after 10 people on board came down with coronavirus.
Authorities locked down the Diamond Princess in Yokohama, Japan. More than 3,700 passengers and crew are stranded on board.
Here we had a cruise ship isolated. There was one case initially, wasn't it? And it was a guy from Hong Kong, and then they could follow it. So they got a lot of information from that. It's a real experiment in a way. It's almost like you've got, I hate to use the analogy, but mice in a lab and you infect them. So you drop one mouse into a colony and see, and they do this with infectious diseases all the time, remember? So now you see how far it spreads and so on.
Scientists test those on board for the virus and discover a shocking secret.
The big thing that emerged was asymptomatic spread.
The virus can spread from people who show no symptoms at all.
They could measure all the people, see who was positive for the virus, and see who never had symptoms, you know?
Of more than 700 who test positive, around 1 in 5 show no symptoms. It's a game-changing discovery. This deadly infectious virus has a stealth mode, capable of moving through populations without their even knowing it.
This asymptomatic spread made it very dangerous. It's not like SARS. You see, with SARS, it was symptoms and you spread, and you could track the people with symptoms and isolate them, and that's how they managed to repress it. With this, lots of people walking around with the virus, no symptoms, and they're spreading it. And that's why it begins to spread like wildfire.
Scientists can now see, thanks to these silent spreaders, that stopping the new virus will be a Herculean task. Hospitals in America start preparing for the worst.
Almost overnight, there was a massive to-do list. If you remember the movie The Magnificent Seven, you heard that the bandits were getting ready to ride into town. And so you're digging the trenches, and you're teaching all the farmers how to shoot guns, and you're sharpening pikes, etc. There was this massive frantic concern of trying to get ready before the cases arrived.
Scientists estimate each person with the virus will infect around 2 to 3 other people. If nothing is done, the outbreak will grow so fast that it can overwhelm the system.
We want to smooth the epidemic out, because if you don't do it, at the peak, one gets an overwhelming number of sick people.
Mathematical modelers are working on how to flatten the curve of the epidemic. In the UK, Julia Gog is using data about how the virus and the population behave to predict how quickly it might spread.
It's like a computer game. You put in where we are now, and you let it run, and you see what happens next.
A single case can trigger a chain of infections.
The country can catch fire.
As the fire takes hold, the only way to dampen it down is to stop people from coming into close contact with each other.
First time I put a lockdown into a model, I put my max length lockdown as 2 weeks, because I could not conceive of UK having a lockdown for longer than that. I just thought it'll be total civilization meltdown. We can't do this.
For governments, deciding when to lock down is not easy.
The optimal strategy to handle the epidemic from a pure transmission point of view would have been to go into lockdown in January and stay there forever. The point is, we advise on the epidemic side, you've got to pull in the economic side. If we go into a deep recession, it's going to hurt the most vulnerable people.
It's terrible to think about. The only thing worse than flattening the curve is not flattening the curve. But a flattened curve is still horrendous.
By late February, President Trump is still resisting stronger action.
It's going to disappear. One day, it's like a miracle. It will disappear. And from our shores, it could get worse before it gets better. Could maybe go away. We'll see what happens. Nobody really knows.
To understand the president, you have to remember we have an election coming up in November. To admit that this disease was coming, that it could lead to a big disruption in daily life, that it might prompt a big economic recession. It's understandable why Trump would not be itching to talk about that.
President Trump repeatedly compares the new virus to one the world never closes down over.
You want to treat this like you treat the flu, right? And, it's going to be. A
lot of people say, oh, it's just a bad flu. It's not. This is an absolute killer. Crude case fatality rate is similar to the case fatality rate that we've seen in West Africa with Ebola. And then people will say, oh, Ebola, that's really bad, but COVID's not bad. Well, I'd say, actually, if you get a bad dose of COVID, your chances are just the same.
To cut through rumors and misinformation, Americans increasingly turn to Dr. Anthony Fauci to explain the science behind the coronavirus.
He's our top expert on infectious diseases, and he has been in that job since 1984, which is the year I was born. He has served in 6 different presidential administrations. He played a huge role in the HIV/AIDS epidemic and everything since then, swine flu, Ebola, Zika.
When you're dealing with an emerging infectious diseases outbreak, you are always behind where you think you are if you think that today reflects where you really are. Therefore, it will always seem that the best way to address it would to be doing something that looks like it might be an overreaction.
Fauci advises Americans to avoid large gatherings. Schools and workplaces begin to lock down in parts of the country. But those decisions are left to local governments. There is no national mandate. At the time in March, Fauci does not endorse wearing masks. Authorities fear the public will hoard supplies and there won't be enough for healthcare workers. Experts would later emphasize the importance of masks to contain the spread of the virus.
We know now that masks are very important. We definitely know that if you're sick, whether you know it or not, it can help stop the virus from spreading to other people. And there's also emerging evidence that it can protect you even if you're not sick from catching it from other people.
New York is fast becoming the new epicenter of the global pandemic as infections rocket. By the end of March, the city accounts for nearly a third of America's 100,000 cases of coronavirus.
It was absolutely frightening. I live in Brooklyn. Just every day, every week, it got worse and worse and worse. You would hear these horror stories from nurses and doctors and EMTs about not having the supplies they needed to keep themselves safe. It was very scary, and watching the case counts rise, just the steep rise, and it was hard to know when it was going to end and how bad it was going to get.
At Mount Sinai School of Medicine, one researcher is working on samples from COVID-19 patients.
I thought we were well prepared, but then reality happened. Case numbers exploded, and the hospital was really overrun.
Viviana's team is trying to map the spread of the virus. What she discovers is surprising.
We could see that the viruses that basically seeded New York City resembled viruses that had been circulating in Europe.
President Trump's ban on travel from China had not stopped the virus. It arrived in New York from Europe. Blaming the European Union for failing to restrict travel from China, the president acts.
To keep new cases from entering our shores, we will be suspending all travel from Europe to the United States for the next 30 days.
But it's too late. The virus has taken hold. By the end of March, more than 265 million Americans are under lockdown. Just 3 months after the virus was sequenced, 70 candidate vaccines are already being developed across the world. The scale and speed of the effort is unprecedented. One of the most advanced is in Oxford in the UK.
Everybody wants to know when will the vaccine be ready, and we've asked it so many times. My inbox explodes every day, partly with a lot of press contacting us from all around the world.
The Oxford vaccine uses the genetic code for the spike protein on the surface of the coronavirus that it uses to invade cells. Because the vaccine resembles the virus, the hope is the immune system will learn how to attack it. It typically takes 10 years for a new vaccine to go through animal and human trials to test whether it's safe and effective, and then licensed and produced at scale.
We're actually working on many stages of vaccine development all at the same time. We have different stages overlapping, whereas normally they'd be done one after the other. It's exciting, it's stressful, but we are under a lot of pressure to deliver this vaccine.
As countries lock down, the spread of the virus is slowing, but it hasn't gone away.
We need to move really quickly because pretty much everybody in the world is likely to be infected, if not this year, then next year or the year after. And so we could potentially still see millions of deaths.
Developing a vaccine against a new virus is a huge challenge.
One question is, if humans get infected with COVID-19 and recover, are they then immune to re-exposure to the virus? That's important because historically it has proven much easier to develop vaccines for viruses in which the human immune system can naturally contend with the virus.
The best and brightest minds are being thrown at the vaccine question. It might take a year, it might take longer, who knows? We're all again on the edge of our seats now waiting, to see if this is going to work, because that is the ultimate answer.
3 months into the crisis, global cases of coronavirus top 1 million. Nearly 4 billion people are under lockdown. None are untouchable.
We've got some breaking news for you on the Prime Minister's health. Now, I'm just hearing at this moment that the Prime Minister has been taken into an intensive care unit. This is the very latest I've got.
British Prime Minister Boris Johnson joins thousands of others across the world fighting for their lives in intensive care.
When we heard the news that our Prime Minister had been admitted to hospital, you notice society taking a breath, the newspapers just thinking, oh, right, gosh. And he's not that old, and he's in charge, and it's happened to him.
Patients sick enough to end up in the ICU are dying at an alarming rate because there is no effective treatment. As the world becomes increasingly desperate for a cure, the President of the United States has some suggestions of his own.
So, supposing we hit the body with a tremendous, whether it's ultraviolet or just very powerful light, and I think you said that has him in check, but you're going to test it. And then I see the disinfectant, where it knocks it out in a minute, 1 minute. And is there a way we can do something like that by injection inside or almost a cleaning? Because you see it gets on the lungs and
he does these off-the-cuff riffs, kind of almost like he didn't even realize that what he was doing is saying that people should inject bleach into their bodies to protect against the coronavirus. It's really his own credibility that is effective, and it's just laughably wrong and dangerous. I mean, if people were to listen to him literally and do it, you could be in real danger.
Because new drugs take so long to develop, some hope an existing drug might prove effective. Against the advice of his science team, President Trump promotes hydroxychloroquine, a malaria drug that has not been proven to work for coronavirus.
I happen to believe in it. I would take it. As you know, I took it for a 14-day period, and I'm here, right? I'm here.
This drug may not work at all. And so President Trump saying how wonderful this is has had a large effect. First of all, in drug supply. Because it's available and can be given off-label, people want it, it's being used, the drug supply is not there. So he is over-promising a situation. It's unrealistic, it's unreliable, and it's made our job harder to run clinical trials and learn.
But the race to fight the virus is sparking innovation. For years, statistician Dr. Scott Barry has been working on a method for testing lots of drugs quickly. The goal, a treatment for pneumonia. Then the pandemic hit.
You watch the news and you see what's happening, and I really feel like I can help.
A traditional clinical trial could take 2 years to set up, and typically tests one drug against a placebo. Using complex mathematical modeling, Scott's approach is different.
It's a global trial that investigates many therapies simultaneously. It's adaptive, that it brings on new therapies continuously, and it assigns patients to the therapies that are working better, and it's pushing things out that aren't working.
Derek Angus has helped turn the new approach into one of the largest clinical trials of its kind. ICU doctors in 200 hospitals around the world are treating COVID-19 patients with thousands of combinations of existing drugs.
If you have 5 drugs that work, and they all work in different ways, and they all independently cut the morbidity and mortality by a relative 15%, we might cut the death rate in half.
It's one of
bring you some breaking news now. The Prime Minister has now been discharged from hospital and he will continue.
Today came a stark reminder the virus still has the nation in its grip.
For 4 months, the world's scientists have worked together like never before, predicting how the virus will spread, researching how countries can flatten the curve, pursuing vaccines and treatments. Even so, the pandemic's rising human cost is inescapable.
It's actually been pretty miserable. We initially plot a person who's having died or survived as a little circle. And in about the second or third week, we had so many cases that we could no longer plot them as individual dots. And that was a shocking period. And then after that, the psychological impact of seeing these deaths just rising day on day on day was quite damaging to a lot of us, and I found it quite upsetting. The hard data we're generating does not give any understanding of the misery, the tragedies that people have had losing their friends and their family, and the isolation.
In labs around the world, the scientific race is on to test a coronavirus vaccine.
In Oxford, Sarah Gilbert's vaccine team is making quick progress. The candidate vaccine has passed safety tests in animals and is now ready for human trials.
We got to the point where we are now of having the first batch of vaccine in the vials, ready to use in the clinic, just going through the testing procedures at the moment, and a big team ready to run those clinical trials and expand them as fast as possible.
Already, 5 other candidate vaccines are being tested in early human trials in China and America. Andrew Pollard is running Oxford's vaccine trial.
We want everyone possible to succeed, because it might not be our vaccine that's the one that works, but the world needs several of these vaccines to be successful, because we have 7 billion people who may need to be vaccinated in the years ahead. And no one vaccine is likely to be manufactured at that scale.
His team is recruiting thousands of volunteers to take part in the trial.
In the trial, we have 2 groups, half of whom get an unrelated vaccine, a meningitis vaccine, which will have no impact at all on coronavirus, and the other half get the new vaccine against COVID-19. And if, over the next few months, any cases that occur are in the control vaccine arm and our vaccine prevents disease, we'll be able to know that it works.
Most childhood vaccines developed over years are effective for 85 to 95% of the people who get them. The FDA hopes a new coronavirus vaccine will protect at least 50% of people getting it.
Well, I think we're optimistic about the vaccine that's being developed here because it's based on a lot of experience with vaccines like this.
In May 2020, Texas ends one of the shortest lockdowns in America, the governor eager to restart the economy.
Governors know probably better than anybody, the economy being closed means people will die too.
The country's top infectious disease expert is alarmed by the possibility of states opening too soon.
The consequences could be really serious. That if some areas, cities, states prematurely open up without having the capability of being able to respond effectively and efficiently, my concern is that we will start to see little spikes that might turn into outbreaks.
Soon, other southern states relax lockdown measures, and the virus takes off.
In places like Texas and Florida and Arizona that had this wave of deaths and cases, the death rate hasn't been as large as it was in New York and in March and April. And we don't know why that is. Is it because, the most vulnerable people aren't getting sick? Is it because of treatments? We don't really understand that yet. But it does seem like a lot of places are making these trade-offs and they're deciding that a full lockdown isn't worth it anymore. For political and I think economic reasons that are really valid.
By June, much of the world has made progress in slowing the virus. But America's eagerness to reopen is about to bring a deadly reckoning.
Okay, move, everybody move. Everybody out.
Post-lockdown America, Memorial Day weekend.
You can't tell who's infected. And so that's why you have to continue to social distance. That's why you need to continue to maintain 6 feet apart.
In Missouri, video captures revelers partying as if there is no pandemic. The scientists' battle with the virus is heating up. One early fear was that the virus could mutate, becoming more infectious. But while they've seen thousands of minor genetic adaptations, it's changing more slowly than a flu virus.
At the moment, the good news is that this virus is not changing very much. And so that means it's a very tractable target. If it continues not to change, means that it'll be a really nice target for vaccines to go after.
The US government is committing billions of dollars to speed up vaccine development. In Oxford, Sarah Gilbert's candidate vaccine is one of those receiving funding from President Trump's Operation Warp Speed, securing 300 million doses for the US.
We would hope to have the results and have a lot of vaccines start using towards the end of this year. But it really does depend on many factors that are outside of our control.
Ironically, the UK's lockdown success means it's harder to test the vaccine there.
You need people to be getting infected, otherwise we can't tell if the vaccine's working. So, because transmission is so low in the UK now, we're not very likely to get a result on vaccine efficacy in the UK anytime soon.
Oxford starts testing the vaccine in Brazil and South Africa, where levels of the virus are high. In July, Sarah and her team reach a milestone in the battle to break the grip of the virus, publishing results from the UK human trials.
It is safe, the researchers at Oxford University announced today, and has induced an immune reaction.
Yeah, it's great. We're very pleased with it. We can publish it. It's been peer reviewed, it's been scrutinised by experts, and now that publication's out there.
More testing is needed to show if the Oxford vaccine protects at least 50% of those who get it. But already they're scaling up production. Dr. Sandy Douglas is in charge of how to make millions of doses safely.
It's been the hardest period of work I've ever done. I lost 4 kilograms accidentally in February without noticing.
Already, Sandy is thinking ahead to which countries will get the vaccine if it proves effective.
I've lost quite a lot of sleep about this. The worry is that it comes down to, raw political power and money. We have been trying actively to ensure that the vaccine will be distributed around the world with real thought for the needs of all countries, including low-income countries, from the start. We wanted manufacturers in Europe and in the US and in China and in India. So no one country can say, we're not going to export it.
But the best efforts of science could be stymied. One poll suggests around 1 in 5 Americans might not take a vaccine, even if it's shown to work.
There's this growing group of people who are not anti-vaccine. These are people who get their vaccines every year, and they do not want the COVID vaccine. They don't trust Trump, they don't trust the government, They think that this is being rushed out way too fast. I think it's a huge problem.
As the pace of the pandemic has slowed in many parts of the world, the United States has seen a dramatic rise in the number of new infections.
America has registered another new daily high in coronavirus cases. And the country's...
In the absence of a vaccine in the U.S., the race for a treatment is even more urgent. So far, drugs that attack the virus are proving less effective than drugs that target the body's immune response.
It's actually unlikely that we will get a single treatment that will essentially fix SARS-CoV-2 infection. But once patients are sick, much of the sickness is not just the virus, but also the body's response to the virus. And even if you stop the virus from replicating at that point, you're still left with the fact that the body's immune system has gone completely awry.
New studies show that President Trump's favorite malaria drug is a bust.
Hydroxychloroquine has been given essentially as an antiviral, although it does many other things. And it's not looking like it's a very effective antiviral, at least so far.
So far, the only drug shown to save lives is an anti-inflammatory drug.
Our colleagues in the United Kingdom have already come out with a result suggesting that dexamethasone can improve outcomes, which is fantastic news.
Dexamethasone appears to cut the risk of death by 1/3 for patients on ventilators. It's cheap and widely available. But another drug demonstrates the problem of scarcity in a world crying out for cures.
The United States brought up all the world's supplies of an antiviral drug, remdesivir, which can cut the recovery time of COVID patients.
Critics accuse the U.S. of monopolizing remdesivir, which has been shown to reduce recovery time for seriously ill COVID patients.
You have to be explicit in how you distribute the drug. You can't just stand up and say, I'm the wealthiest, I want all the drug, or I paid for it. It's a challenge for politicians.
The first wave of the pandemic has brought a terrible cost in lives and treasure.
COVID-19 is the 21st century version of a world war, both good and bad. It's an opportunity for human beings to come together. It's an opportunity for human beings to be shown up as being incredibly fractious, capricious, and selfish. And it's really about how we choose to respond.
Their common foe has galvanized the global scientific community like never before.
I think it will go down as a good thing, that the COVID-19 crisis has brought us together as a community. A lot of collaboration's happening, which is tremendous.
The number of clinical trials in the search for COVID treatments and vaccines has rocketed to more than 4,000.
We are not racing against other groups making a vaccine. If there's a race at all, we're all racing together against the virus and the pandemic.
The extraordinary scientific effort is bringing hope. The tide will be turned against the virus.
We're very optimistic. We really think that we have a very good chance of making this work.
We all feel we're in this together and we've got to beat this as a team.